Alright class, we're moving right along. We're going to explore where these fractional or rational exponents might come from. What does it mean? I'm going to keep it simple. Okay, I'm going to ask you a bunch of multiplication questions that involve the same base. And so you can tell me what the exponent is supposed to look like, and we're going to talk a little bit. Okay? Let's do this. 5 times 5. As an exponent, what number fits? Okay? Because we're going to address the question, what is a square root of a number? 5 times 5 is going to be 25. And so if I reverse it, 5 is the square root of 25, right? Because 25 comes from 5 multiplying by itself. So you can also write it as 5 squared. Anyways, 10 times 10, that would be 100. So 10 is the square root of 100. So, and I could write this as 10 to the power of 2. So 10 is the square root of 100. What about if I take out the actual value of the base and just put a generic x variable? X times x would be written as x squared. So you can say that, what? X is the square root of x squared, right? X is the root of x squared. What about this? X to the power of 3 plus 3, that's a 6. So you can say x to the power of 3 is a square root of x to the power of 6. Do you see a pattern? In terms of exponents, the square root is half of the exponent here. The square root, half the exponent here. Let's keep going. X to the power of 9 times x to the power of 9 would be, added up, x to the power of 18. So you can say x to the power of 9 has to be the square root of x to the power of 18. If you can understand the pattern, we have a thing going, and we're going to be in a good spot for talking about fractions. 9 is half of 18, 3 is half of the 6, and 1 is half of the 2. A square root is essentially half of whatever the exponent is. Remember that. The square root exponent is half of whatever we originally had. So what does a square root mean? Here's the million-dollar question for today. You know that if the base is the same, the exponents will add. What plus what gives you 1? Or rather, if the exponent is 1, what is the square root of x to the power of 1? So 18, half was 9. 6, half was a 3. If it's a 1, half would be just half. In other words, if I have 1 over 2 times x to the power of 1 over 2 times x to the power of 1 over 2, half plus half equals a whole. Right? Interesting. Let's leave the rule out for now. I don't think we've quite hammered it home just yet. Oh, I was wrong. I thought there was something else that we need to talk about. So in the same idea, I can tell you a story. You know that 2 times a 2 is a 4. But you can also say 4 is 2 to the power of 2 because it's 2 to the power of 1 times 2 to the power of 1. It's 1 plus 1. But what if I have a 2? So what is half of that? Well, wouldn't that be half? What is half of that? It would be this. Same idea. But maybe you'll believe me if I write it like this. What is, if you can say that, hey, square root of 4 times a square root of 4 should give you 4, right? I can write this as 4 to the power of half times 4 to the power of half equals 4 to the power of 1. So having an exponent of 1 over 2 is the same as doing a square root. Same as doing a square root. So what am I trying to get at? If you see an exponent with a fraction, the denominator is equivalent to the root. So in the square root, that's going to be a 2. Okay? So I'll write this, the rule. The denominator of the exponent is the root. Let's call it the nth root of the base. It's a little bit weird to just read that and understand it. It's better to see it in action. So when, if I could ask the substitute to stop the video and then continue when everyone is ready to move to the next page. Okay. So here's an example. Ready? 16 to the power of 1 over 2. Notice how the denominator is a 2. That means it's going to be a square root. In other words, this. So that is equal to 16, a square root of 16, which is going to be a 4. The same thing here. Notice that denominator is a 3. That means it is a cube root. Now you can plug this into the calculator to solve it if you want, but the more you practice, I'm hoping you become very comfortable even doing it in your head. So watch this. Okay? If I have a power, you'll see the exponent on top actually is the numerator of the fraction. We can treat it as a normal exponent. The denominator, treat it as the root, and the base is just the base. So here, take a look. We have, this is my exponent, that's my root. X to the power of 2 over 3 can be written as the third root of x to the power of 2, right? Because that's my root, and that's my exponent. Or you could actually write this as the other order. The third root of x, and once that is done, all of it is squared. You might be wondering why. I can explain it to you in detail after. You're probably so focused on trying to understand or memorize this, but you can rewrite this using power of a power. Because if I have x to the power of 2, all to the power of 1 over 3, the exponents multiply, giving me 2 over 3. If I have x to the power of 1 over 3 first, and all of that is the power of 2, the exponents will multiply, giving me 2 over 3. I digress. Let's talk about this. 3 over 4. The 4 is the denominator. The 3 is the numerator. So I can write this as the fourth root of x to the power of 3, or power of 3 of the fourth root. Whatever you want to do first, it is possible. That's it. And we can do it in reverse. Please remember, if you see this as the root, aka the index, I'm not going to test you on these terminologies, but if you say this is the index, you can rewrite that as the denominator. If you see an exponent, or if you don't see an exponent, then you know by default the exponent is a 1. You can write that as the numerator. So check this out. Here we go. That's the root. So that turns into the denominator. Here's the exponent. That will be the numerator. And here's the base. If I take this radical and turn it into an exponent, this would be x to the power of numerator over denominator. Same thing here. This would be 8 to the power of numerator over denominator. Same thing. This would be 7 to the power of numerator over denominator. Okay. And that's pretty much it. So here's the rule. Remember, if you see the root, that's a 2, that becomes a denominator. If you see the root, that becomes a denominator. If you see the root, that becomes a denominator, and by default, whatever the root is in the denominator. So you should be able to try to calculate these without a calculator, right? 100, a big denominator is 2, so it's just the square root of 100. So you ask yourself, what multiplies with itself 2 times to give 100? That's a 10. Here's another one. Denominator is a 4. So this is the 4th root of 16. What multiplies with itself 4 times gives you 16? 2. And you can test it. 2 times 2, which is 4. 8, 16. It checks out. We'll do a hard one. Even here, it's just a matter of your, number sense. 1 over 3 means this is the 3rd root of 216. 2 times 2 times 2, 8. Too small. 3 times 3 times 3, 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. The answer to this is just 6, because 6 times 6 times 6 gives you 216. With remaining time, whatever remaining time you have, I'd like you to complete this handout. Work through as much of this as possible. I'll do one more examples here with you. All of the questions in this handout you should be able to do. Like here, don't get it twisted. Let's do this very last one. How do we work through this? Well, first I see a negative. I don't like that. So I'm going to rewrite this as 121 in the denominator. And so, what is a square root of 1 over 121? Well, the numerator is easy. 1 times 1 gives you 1, so the square root of 1 would be 1. What times what gives you 121? 11. And that's the end of the question. It's not easy at first, but that's how much practice you will need to get the hang of it. And be efficient. Don't make careless mistakes. Okay. Your homework task will be to try and finish all of the exponent questions. The 7.3 is a bit much, but for this one, I really feel you can complete all of the blanks in the worksheet provided. Okay? Good luck. We'll see you tomorrow.